surfaces. Can we do those?
Yes, we can.
Yes, we can.
Okay.
That's like
8.
That's like possibly.
So it's a straight line, so obviously we're going to parameterize this in terms of u and v, and what we're going to do.
straight line.
Yeah. Line segment. Okay, so
Can't you just do a T?
Full.
Can't you just do T?
2 plus.
yes, it's a curve. It's a straight line. There's one variable. Okay? It's our t. How does it look?
X is going to go from
2
to 2T, so 2 plus
2
2T.
plus 2t.
Yeah, 2 plus 2.
Right, so remember here, you start with the initial point, and then this is
Change.
what you should add or subtract to get to final point. And then attach a t to it. Right? Right, so I gave an explicit formula for this, but if you're just, you can actually just, these are pretty easy, you can just look at them and know what it is. You don't have to go through the whole formula. I think it was like x initial plus x final minus x initial times t. It's doing exactly this, right? And what was the second component?
3 minus 10t.
3 minus 10t, right? When you start at 3, to get to minus 7, you need to subtract 10, right? And then you let t go from 0 to 1. Right? If you use that formula, it's always 0 to 1. With this method. Yes?
This would be a parabola, I'm not saying, but if the endpoints are 2, 3, and whatever, 4, 6, then if I choose, for example, x to be t, then my limits are whatever is x.
Okay, let's do another example that covers here. Say the part of the parabola y equals x squared plus 1 from the point 1, 2 to the point 4, 17. Let's make this a little bit more interesting. 2, 5. You think of an example like that, right? So, again, remember we said that when we were parameterizing, there are really 3 basic categories we think of. Parameterizing straight lines, in which you just do this easy method here. Parameterizing circles, which you use sine and cosine. You know, x equals r cosine, y equals r sine, for example. And parameterizing anything else. This falls into the category of anything else. It's a parabola. It's not a straight line or a circle. So what you do is you parameterize in terms of the independent variable. Solve for everyone in terms of one guy, and let that guy be the parameter. So here you could say that x equals t, which means that your y would be t squared plus 1. Right? And so your r of t would just look like that. T comma t t squared plus 1. And since x equals t, the t limits just follow the x limits. Right? Because they're in fact the same guy, right? I just changed the name to protect the innocent. Right? So now, so now this would mean that so t would go between 2 and 4, right? Because my x limit starts at 2 and it ends at 4. So those would be my t limits, right? So I say always 0 to 1 with this method only. Of course, if you're in a different context, your limits can change. But if you do a straight line using the formulas I gave you, it's always 0 to 1.
Is it possible to do like 2 dimensions
Come in, 291.
for this?
Come in.
Use U and V.
No, if you use a U and V, you're a surface. You're no longer a curve.
Oh, okay.
So,
Yeah, it depends.
Hmm?
It depends. If it's no longer, what do you call it, a function, it's just numbers, like a rows of numbers, then yeah, it can be 2. But actually there'll be no variables in that case.
what do you mean? I don't know.
Jhevon,
Never mind. I'm thinking of no variables, not 2 variables, not 3 variables.
Jhevon, your battery's about to die.
Okay.
I guess
It's over, wasn't it?
maybe we can get through the rest of these really quickly.
No, not gonna happen.
Huh?
Not gonna happen.
Let's see.
Do you have the battery?
What does this one look like?
Uh, 1 minus t, yeah.
1 minus t, 2 minus 5t,
3.
3 what?
3 minus t.
3 minus, no, 3 plus t.
Oh, sorry.
How about c? C?
2 variables? No, wait.
It's just a triangle with a circle, right?
It's not a triangle.
No,
Well, that's surface.
it's a circle.
Yeah,
This is
circle.
a cylinder and you're slicing it with a
Yeah,
plate.
it's a cylinder.
How would you do the cylinder?
It's a cylinder going out the Y.
Polar.
One thing you can do is let x equals r cosine theta, right? 2
Yes.
cosine t. Your z would just replace the y to sine t, right? And so this means that if you have x plus y plus z equals 1, then that means you have 2 cosine t plus y plus 2 sine t equals 1. So your y is just 1 minus 2 cosine t minus 2 sine t. And so that would be your r of t. X is 2 cosine t. Your y is 1 minus 2 cosine t minus 2 sine t. And your z is 2 sine t. And of course I could, it's going to be a full circle. If you drew the picture, it would look like this. You have a thing cutting here. It's going to revolve fully, so you can just like this.
It has to be. It has to be short.
It doesn't, they could define, say, oh, we only want the right half or the left half. They could say whatever they want.
Seriously?
But here I just said, do the whole thing. But D, I want to actually do a surface, right? What's the difference? It's very similar. Notice that the things look very similar, but how would it change the fact that I'm doing a surface?
Well,
For C, we can still do double variable, like 2 variables.
It has to be 2 variables, U and V, right?
I mean, for C, we can do 2 variable too, right?
no, you don't.
No, we can't.
No.
We could,
R is
right?
constant.
No, we can't.
R is a constant.
You could do theta and t, or theta and
Theta is
Yeah. What if I want to use U and V? How do I change it?
for which one? D or B?
For C, right? We
No.
can we
I'm
do?
doing D, right?
I mean,
I don't want to
Couldn't we finish
parameterize
D
the
first?
curve anymore, right? This is parameterizing that curve C. What if I wanted to parameterize this whole surface? the surface itself.
Then you need to give you an R there, so there has to be something to.
Right, there has to be a variable in the radius, right? Because your radius extends from 0 outwards, right? So
Yeah.
this constant 2 can't be a constant anymore.
So
It has to be a
we'll put
variable
R.
now. So you can do just u cosine v, comma u sine v, right? And then the inside you just would be 1 minus u cosine v minus u sine v. And then you let u go between 0 and 2. Where was this one? In this case, it's this guy, so 0 to 3. And your v goes from 0 to 2. And since battery's about to die, we'll take a break there and we'll